Hey everybody, this is Ben and welcome back to my Leetcode series. And today we're going to be looking at problem 2405 titled Optimal Partition of String. So we'll read through the prompt, we'll talk about the pseudocode and an example, and then we'll code up the problem together. So given a string S, partition the string into one or more substrings such that the characters in each substring are unique. That is, no letter appears in a single substring more than once. We'll return the minimum number of substrings in such a partition. And note that each character should belong to exactly one substring in a partition. So let's go ahead and talk about this problem in depth. So the approach here is pretty simple. We simply need to begin a new substring when we hit a character that we've already seen in our current substring. So how can we do this? We can use a hash set to keep track of the characters we've encountered in the current substring. So let's go ahead and walk through the pseudocode. And just as a rule of thumb for this problem, remember, anytime we hit a character we've already seen, we will clear our hash set and we start a new one. Okay, so keep that in mind as we go into this problem. So in the pseudocode, we'll go ahead and create a hash set. We'll create integer I just to iterate through our while loop, and then we'll have our result integer as well. So while I is less than s.length, and s is our given string for this problem, so if our hash set contains the current value, we will iterate our result variable, just add 1. We'll clear the hash set. This is because we are now going to start a new substring. And note, we do not iterate I in the if statement. Since the character at I is already in our current substring, we need to make sure we start our next substring at this character. And then we'll just use the continue command to go ahead and go back to the top of our while loop. So if this if statement doesn't catch, what we'll do is we will add the character to our hash set, and we'll iterate I to move to the next character. We end our while loop, and then we'll return result plus 1. And the plus 1 is really important. We have to return result plus 1 because our last substring will not catch the if statement, as there are no repeating characters. So whatever our last substring is in our partition, it has no way of catching this. Since it's a unique substring, there are no repeated characters. So we need to make sure we add 1 to our result to account for that happening. So let's go ahead and break down an example. Let's say our string S is this right here, ABA, CABA. So first we need to initialize a hash set, initialize our integer I, and initialize our result variable. So let's walk through every iteration of our while loop. So when I equals 0, our current character is A. The if statement misses, so we're going to add that character to our hash set. So here's what our set currently looks like, right here. And then we iterate I. Going to I equals 1, our current character is B. The if statement misses. We add B, which is this right here, to our hash set. So this is what our set looks like now. And we iterate I. Now things get interesting when we get to I equals 2. Our current character is A, so our if statement catches. That means we need to iterate our result. See, our result now equals 1, which represents our last substring. So this is what was just in our hash set. So AB. We clear the hash set, so now it's empty. We're erasing that AB out of there, and we continue. Because we need to start at this character again for our new substring. We need to make sure it's counted for because it existed in the last one, so we need to start at it now so we don't iterate I. So again, as you can see, we'll be at I equals 2. This time the current character A, if statement misses, we add A to our hash set, we iterate I, and here's what our set looks like. Going to I equals 3, current character is C, if statement misses, so we add C to our hash set, iterate I, and here's our set. Now I equals 4, our current character is A. The if statement catches because the hash set contains A. We iterate our result, and result now equals 2. So we have AB, and we have AC. And we're not actually storing these strings, we're just storing the value here is all we need by logic. We clear our hash set, and we continue. So again, I equals 4. The current character A, if statement misses, add A to our set, increment I, set is just A. I equals 5. Current character equals B. If statement misses, we add B to our set, increment I, and here's our set, AB. I equals 6, our current character is A. So the if statement catches. Our result, we increment. Now we have 3 items in our result, AB, AC, and AB. Clear the hash set, continue. Again, I equals 6, current character A. If statement misses, add A to our set, increment I, set equals A. And we end our while loop because I is now no longer less than s.length. And we're going to return, as we talked about, result plus 1. Because as you can see, we ended with a set that had a value in it. This set isn't empty, so this represents a new substring. We have to account for this because that last substring will not hit the if statement. And that's because there are no repeating characters. So because there will always be unique characters in our hash set by order of this code, the substring left is current in the hash set. Thus, we have 4 as our result. AB, AC, AB, and then what was left, which was just A. Let's go ahead and code up a solution together. You're going to want to import the hash map library for this problem. So let's initialize a hash set here. Hash set character, we'll call it set equals new hash set. We'll go ahead and say int I equals 0. Int C is going to be our result variable. I like to do C, it's just short for counter. It's just a nice little concise variable. So here's our while loop. Now we have our if statement. If our set contains the current character, which is s.character at I, we're going to increment our result, which I'm calling C. We'll clear our set, and we'll continue. Now if this if statement doesn't hit, we'll just add the character, s.character at I, and we'll increment I. Then we'll return C plus 1. So really there's not much code here. The logic is pretty simple. Let's go ahead and run the program. As you can see, that worked. We'll go ahead and submit it. I'm not sure why that's running so much slower because this is the same exact code I submitted before. But it still is going to work for you. It will pass all cases. We'll take 50 and 50, even though this should really be a lot faster. So overall, this was a fun problem to use hash sets to kind of challenge your string logic, just being able to think about things, because we're not actually storing our substrings in this problem. We're purely just going to count them by the logic of this code. So yeah, just a unique way to think about the problem. And I hope you learned something. Thank you very much for watching.